3. Surprise! Hello everyone, welcome to the Daily Code episode 15. I am Chris, and we're going to do something really exciting today. I hope you had a good weekend. I had a very good weekend. I did some fun coding on Saturday and watched The Walking Dead on Sunday. So that was fun. So today I thought, last week we were doing some really cool stuff with Eris and a little bit with Icicle, and the week before it was a lot of Icicle. And one of the things that was frustrating me was my lack of proper benchmarking, and a few things I was doing wrong, which hugely degraded the performance of the Icicle code, specifically the Icicle code. And so I mentioned last week sometime doing something like creating a cache library, or using a cache library, or implementing it in the site that I was busy with. So Saturday, the cool code that I wrote was that I took hours on Saturday just learning about some of the inner bits of Icicle, how to use promises and deferreds efficiently, how to just generally muck about with Icicle, and wrote some cool code for it, and got some cool tips from Aaron and Stephen about it afterwards. And I thought that it would be an interesting time to combine some of the test-driven development stuff we were doing last week, and learn about promises, basically, like how to write a module in Icicle. So yeah, so I thought that'd be cool, and I'm going to jump right in with that, by the way. So I wrote this thing. I'm jumping right ahead now, but I wrote this thing which is it basically ends up in code like this. So it's a cache library, and there is one implementer of it, and I'll explain this as I go along. But essentially, you can get a cached value, and this yield means this is a value that will be resolved later. If that cache value is not there, you can set it, and whatever this coroutine ends up generating will be stored in cached, in $cached. So it's a pretty simple API, but it's actually super useful, and I'll show you, as we go along, I'll show you how super useful this can actually be. Just to begin with, I've created, that's the backup, I've created a folder, and I have required Icicle concurrent, and the reason I need that will become apparent later on. But this also installs the core Icicle code, which is mostly what we're going to be using. And I thought I'd start off by explaining or showing how promises work. So Icicle has this thing which kind of, I don't really know where it originated from, but the first place I learned about it, promises, were from JavaScript. And I guess I never really understood them very well, but let's try and illustrate what they're for. Okay, so imagine we have a tree of functions. Let's say get input. Say we're trying to process an HTTP request. We'll say get input, and maybe the name of the input variable we want to get, and a callable for then. Like what happens next? Next callback. Call it that. Make it a little bit more obvious. Okay, get input. Oh, sweet. Welcome, Unicode developer. That's a cool username. Okay, so get input, query database, render view. Okay, so here's some code. And this kind of illustrates perhaps what we would be doing if we were processing an HTTP request. So to begin with, we'd say something like get input, and then maybe the input we're looking for is username, for instance. Maybe it's from get, maybe it's from post data. But then we say, okay, what happens when we have this? What is the next input we do? Well, the next thing we do? Well, let's say, okay, if we get the username, so say we pull the username out of the get variables or the post variables, and we provide it to this callback function as an argument, then Well, what do we do with that? Okay, let's say we query the database, and let's change this variable to query, and we say something like select all from users where username is is something where you actually use PDO. Anyway, and let's assume that that row gets given to another callback function, like that. Okay, then what do we want to do? Well, let's render the view. Render view. And here we'll say row is what's given. Well, do we really want to say that? No, maybe template is what we want to give here. So we'll say, okay, render users profile.tpl, and once that's done, maybe we'll do something like output. Okay, let's just make sure all our semicolons are here. Imagine we have code like this, right? Well, maybe what we can do is we can write out how this code would function, but look at what's happening here already. Despite us not having any implementation code, look what's happening here. We have this tendency of code to start going to the left, and this becomes a problem. It becomes a problem when we think of this code in terms of asynchronous interaction. Because if we say, okay, let's assume that this won't get called immediately, that get input will take some time. Okay, so we should give a callback, because then that's the only way we can hook into that thing when it eventually happens. Okay, so let's query from the database, but it won't come back immediately. Maybe what we need to do is, in fact, I'll just even simplify this a little bit. Maybe we're going to have to wait for this row to come back from the database. So we have a callback as another way of hooking in, and so forth and so forth. And we get these incredibly complex trees of stuff, and it's difficult, oftentimes difficult to read and to understand what's going on, because it gets quite unwieldy. It may also not be practical to structure our code in this way. Maybe querying the database isn't part of the userland code. Maybe we don't have access to that. Maybe we just pass this query to some kind of factory, and then what? Do we give a callback to that factory? Is it really disconnected from our code? These are some valid and some quirky concerns that some people have of this. Promises does things slightly differently. If we return promises is a way to avoid this kind of really nested callback structure. It's kind of a way to restructure code so that it's slightly cleaner. Let's give an example. Okay, let's say we have these functions again. Well, promises give us a way to be able to say something like get input, and this will be username. Then okay, then we'd carry on doing something. Now, this looks very similar to this first scenario we had, right? We've just got like a little dot then there. In fact, that would be more PHP accurate code. So it's not very different to this, right? I mean, we've just got arrow then, but what we would return from here, we could return a value, or we could return another promise. We could say something like return query database, query database with the username, or with the whole query, I guess. Let's just do that. Like that. Okay? In fact, we can, maybe it's clearer if we indent it like this. So we can do that. We don't need to pass another callback to query database. But if we're returning a promise, well, then we can do something like this. Then function row. So we move from n levels of nested callbacks to one level of stuff. And another benefit that promises give us is that we can also handle errors in a consistent way. Because in this case over here, well, we could just accept one value, or what is more likely in platforms like Node.js, for instance, we have a second parameter, which is for error. And so we need to do some error checking here, and then we have an error parameter here, and then we need to do some checking here. And so the boilerplate that we do piles up. right? But when we do promises, well, we can do all of the chain of events that should be a successful chain, right? But then we can just catch everything at the same time at the bottom here. So catch function exception, and then we can do something with this. We can handle the exception. Here we can check the type of exception that was thrown. This doesn't have to go at the end. For instance, we can have a catch there and then proceed with this. Now, promises aren't fundamentally different from doing callbacks. They're not. It's callbacks wrapped within a nice UI, a nice API. But they help to structure code in interesting ways. And if we start structuring our code like this, then other topics like observables, which is another big interesting JavaScript and recently PHP thing, then things like observables become easier to use and to code in. So, okay, let's do something practical with this. Let's just delete all of this. And let me show you a practical example of this, okay? I'm going to require vendor autoload. Gee, I hope I've done that description justice. Okay, require vendor autoload. Promises are cleaner, yes. Yes. So, okay, require vendor autoload. Now, we have access to, if we use, oh my gosh, Icicle loop. Okay, let's just use this. Now, Icicle implements an event loop, and it does this with a few different providers, and that's great, there are options. But this gives us access to be able to do delayed functionality. How have you ever written code that uses a sleep function because you want to just wait for an amount of time, or that does a date diff? You know, well, we can add timers in the event loop that the event loop will later trigger for us. So we can say something like timer, and after 3 seconds, do a thing like print, it is time to burn baskets. Okay. And because this is an event loop system, we have to start the event loop off. That turns this into a long-running process. So now when we just make sure that I have the correct PHP linked, brew unlink PHP 5.6. Ooh. Okay, so now when we run this, we have a long-running script, and after 3 seconds, it's time to burn baskets. I'll run that again just so you can see it's beautiful. It's time to burn baskets. Okay. We have the ability to do repeatable things. Periodic. That is it. I should just use the auto suggest, but anyway. So burn basket. Cool. So this is happening every second. It's like a timer, but the timer that keeps going at that set interval. Okay, we have access to do this kind of stuff, so we don't need to fall back on the sleep function, and we don't want to fall back on the sleep function because the way that this loop periodic and loop timer is implemented is a non-blocking. It is implemented in a non-blocking way. Other code can still execute within the event loop, and this periodic and time won't stop that. If we use sleep, nothing happens in the script until that sleep is used up. So this is a good approach to do non-blocking time-based things. Okay, how is this useful to our example of promises? Well, imagine we have a data type. In fact, let's have a function to get input. Key. Okay, imagine we have this. And imagine we have some kind of synthetic delay that means that we can't get this value back immediately. We could do something like, say, deferred is new deferred. Let's import that. And then we could say, okay, maybe something takes a long time for this to execute, but it's in an asynchronous non-blocking way. Let's simulate that with a timer. So we'll say, okay, this input actually takes 1.5 seconds to get. Okay. And we'll have to use deferred thanks to PHP's binding, and we'll say something like deferred resolve assertchris. Okay. Now we could return a deferred, but actually a deferred, you can think of, once you see what a promise does, you can think of a deferred as kind of like an internal representation of a promise. I'll explain why. Okay, return deferred. So we don't want to return the deferred, we just want to return a promise version of that. So we'll say deferred return promise. In fact, I'll just resolve key here so that we can see that this is dynamic, and I've got to pass it in. Okay, let's try this out. Let's say something like get input. Okay. First I want to see what value is here, but I also want to start the loop. Because it's event loop based and we're using the loop inside here, we may as well start the loop down here. Okay, let's see what value is here. I'm doing something wrong here. Okay, so I'm not returning this. There we go. Okay, it's a promise object, and because this timer runs past 1.5 seconds and there's nothing else in the event loop just stops itself, right? But in any larger system, you would constantly have things going on in the event loop, right? So it returns a promise object. This doesn't return assertchris, as we may think it would after 1.5 seconds. And that's because right here, when this code runs, 1.5 seconds hasn't actually passed yet. Now, what we need to do is we're going to use the yield keyword, so we can wrap that in a generator, but maybe we want to wrap it in a format that Icicle likes. And generators in PHP are syntactic sugar for iterators. They're not, by default, they are not this kind of interruptible function that Icicle or AMPHP or React, in fact React doesn't use generators, but they're not this kind of interruptible function that Icicle or AMPHP uses. They are just generators, they're just an iterable thing. But these libraries have popped up to allow these generators, these usually iterable things, to act like interruptible functions. And other languages call interruptible functions, languages that have them, call them coroutines. So there's a commonality here. Both AMPHP and Icicle call these coroutines. Correct me if I'm speaking out of turn there. But yes, for those in chat who know a lot about this thing. So because we're going to use a generator and because we're going to use it to do asynchronous stuff, we should wrap this in a coroutine. And in Icicle, that looks like use coroutine. Coroutine create. We just wrap a generator function within this coroutine create method. Now, at this point, this is still going to give us promise. In fact, I'll put this in here just to show that this is still going to give us a promise value. And I'll explain why after that. Okay, so let's run that. Broken. Callable did not yield. Okay, well, we need to do yield here to turn this into a generator function. It's still a promise object, and because that 1.5 seconds passes by, the loop terminates. But it's still a promise. What we need to do, because this is now a coroutine, and because this is a promise that we want to resolve, is we need to yield at this point. And then Icicle will wait until this promise's value resolves, and then it will assign it to value. So now when we print this value, we're not going to see a promise object anymore. We're going to see assertchris. Boom. Pretty cool, eh? Okay. This is a very stupid example, but I hope it illustrates that we can start creating APIs that are non-blocking because we're not using sleep. And I'll talk about exactly how we get into the details of that. But we can start creating APIs that are okay with file I/O and network I/O and intense computation taking a lot of time, because we have a way to create a promise of an eventual value. And that's what promises are. Promises aren't immediate values. They aren't just a substitute for doing a lot of callbacks. Promises are the glue that binds together how callbacks actually work in a different structure. And when you get a promise, what you're getting is a promise of an eventual value or an eventual failure. For the most part, we're going to deal with eventual values. I may show a little bit of how to do the eventual failures tonight, but that's the thing. If we start thinking of how we can use this eventual value resolution, we can write really interesting code. And Icicle and AMPHP bind this together so that using yield waits until those things are resolved, which is rad, because we don't have to worry about how that all works internally. We can just start writing APIs that work with promises and resolve things eventually, and then Icicle and AMPHP will do the rest. So, before we take a break in 10 minutes time, I am going to start us off down the path of making a caching library for Icicle, a module for Icicle, something that can be used with it, that we can use to store values that are common amongst a whole lot of different requests. And then we'll implement that in the second half, and maybe even get to testing it then. Otherwise, we'll just do a little bit more practical application of this and see how we can use this and benchmark a bit and have fun generally. But let's focus and let's do some tests. Let's do some test-driven design. Does that sound good? Are there questions about promises, by the way, that I haven't prattled on enough about? Any questions? Just let me know. Okay. Now I'll just make these source files for the moment so that you can see what the structure of this is going to look like. I want to make an interface for drivers. So a common interface that all cache providers will implement. We're only going to write one, and you'll see which one, but we'll have a common interface so that we can type int against the interface and so that people can do other implementations if they want to. So a driver interface, and then a folder of drivers, and the only one we're going to implement today is the in-memory driver. Okay. Now, let's do some tests first. Because driver is just going to be an interface, we're not going to make a test for it, but we'll have a driver folder. Oh, typing is terrible tonight. And then we'll have a memory driver test file, so that PHP will pick this up and run with it. Let's just get a PHP unit.xml file in here so that we can test that so that we can actually run the tests. That would be a good start. Okay. And the namespace, we're going to put this all in. I'll just put it in Icicle namespace, of course. Namespace Icicle cache for now. Okay, so Icicle cache will be like the package namespace. And it's kind of cheeky of me to call it this because it's not official. And nothing I show you tonight is Icicle official. It's just fun. Okay, so Icicle cache test driver. It'll make more sense when I structure the other stuff. Class memory driver test extends. Okay, and I also need to, while I'm here, I probably need to composer require for dev PHP unit. And Icicle IO HTTP, just for later testing. Is that even possible? Can you even do that? Okay, I'll do this. Okay. While that's downloading, we'll extend PHP unit framework test case. And we'll also need to import this because we're in a namespace, so use that. Okay, everyone following along? Anyone have any questions? You're awfully quiet. Tell me, are you concerned? Okay, we'll make 3 tests for this because right now I'm interested in doing just 3 methods. So public function test value set, public function test value not set, public function test forget. Okay. Hi, Greg. Hi, simulated Greg. Hi. Okay. Why are you concerned, Greg? concerning you. Okay, the stuff's downloaded. Okay. Now, let's think about the public API of this caching interface. We want to have a way to get values. Let's go back to our example as well, because that's helpful. We want to have a way to get values. So, how do we get something that's already stored in cache? And if that value is not stored in cache, how do we set it? We probably need something like this, where we can give a key and a value, or something that will resolve to a value, so that that can be set. But look, we're also assuming that whatever happens in the second argument, that gets passed back after it's already been set in cache. Does that make sense? Most of our requests will get a value immediately, and that's fine. The first few, or the first one, should be able to set it and get the value that was resolved in the end. So that seems like a reasonable API. Something that's not shown in this example is, well, we probably want a way to be able to remove stuff. And so, that being the case, let's think about how these things can be structured. Let's also just create this class quickly. In fact, let's create this interface quickly first. Interface, namespace, Icicle, cache, and this interface will be driver. Okay. We'll give these public methods here, so something like public function get with a key, public function set, oops, really messed that up, function set with a key and a value, public function forget with a key. Hi, Ride the Fire. Hi, Uncle Carbs. Sorry about the lag, folks. Ride the Fire, I am making a cache library to be used alongside Icicle, the asynchronous set of libraries. It's pretty exciting. At the same time, we're learning how promises and deferreds work and how they help us to structure our code better. Yes, module for Icicle. Okay, so this is the public API that we spoke about when we were looking at what tests we wanted to write. So if you remember back to the TDD daily I did last week or the week before, I skip over the part where I actually call functions here and they fail because the functions aren't made, because I know that's going to fail. Icicle is a set of libraries that help do asynchronous code in PHP. There's a lot of really cool stuff about it in the archives, but stick around and you'll see what we're doing here. Okay, so we've got our interface, namespace. Let's copy some of the namespace to here. Ooh, namespace cache, driver. Okay, class memory driver. Oop. And this implements the driver interface that we just did, and we have to do stub methods. Yay for stub methods. Okay, we have empty methods here. Let's start by defining what this should look like. Let's say something like cache is new memory driver, and because this is PHP Storm and that's awesome, it's imported that namespace that we just defined. Okay, so now by default we've got this method that says get, right? So it's going to get a value that is stored in the cache. But what if there is no value for that key stored in the cache? Well, it seems to me that could resolve to a null value. We don't know that it's going to resolve immediately, because this could be a memcache implementation that has to go over the wire, and we don't want to do that. So we'll say something like value is, in fact, we'll just change this, which will become clear why. Expected equals yield cache get unset key. And this could be anything. I mean, I could just change this to anything. Could be anything. And then what we want to say is this assert null expected. In fact, that's not expected. This is actually actual. But the expected is null. Okay, this seems to make sense. And if you've done a lot of TDD before, this might look like a familiar thing, except of course for the yield. But this isn't going to work, and I'll show you why this doesn't work. We've required PHP unit. Okay, so PHP vendor bin PHP unit. In fact, I can take the first bit off as well. You can just do vendor bin PHP unit. No tests executed. Okay. Okay. So the first problem is that we've created these namespaces and we haven't auto-loaded them. So let's auto-load them. Auto-load PSR4. And our source folder has the namespace prefix Icicle cache. So that's in source. Okay. Now we also have tests, which are in a slightly different namespace. And we could auto-load these all the time, or we could just auto-load them for dev purposes. So here we could say, in the test namespace, well, that's in the test folder. And how this works is that autoload dev and required dev will only feature when composer install is run on this package. But when this package is required by something else, these won't actually be applied, which is pretty rad. Pretty rad. It doesn't download unnecessary stuff for us. Okay, we need to composer dump autoload. Composer dump autoload. Let's try running the test again. No test executed. I'm not sure if this is because I'm trolling myself or something. Tests. This is in the wrong folder. What did I just do? I don't know what I just did. Remember composer, I said this was the tests folder. Silly me. Okay, 3 tests, 0 assertions. Now, why do you think that is? We have an assert there. We have an assert here, so why do you think this is? Come on, chat. Give me some suggestions. I know why it is. Oh, what did I just do? Sorry, Greg. Sorry, Greg. Okay. So, this isn't being executed by PHP unit. A simple misclick, my apologies. I really should hide these ban buttons, but I like responding quickly to spammers. Sorry about that. I did the same thing to Uncle Carbs, sorry. Okay. So, PHP unit doesn't run this because it sees the yield keyword and PHP unit doesn't test generators. We have to wrap this in something. Remember what we had to do when we wanted to wrap the promise stuff? When we wanted to get this to run, we had to wrap it in a coroutine. So let's do that. Let's use Icicle coroutine. Okay, and let's wrap this in a coroutine. So I'm just going to wrap the whole thing in there. Coroutine. Okay. Coroutine create. Now, when we run this, we actually have to run the loop as well, which means we have to use the loop in here. Use Icicle loop. We'll run this and we'll see what happens. Now we have a test and we have an assertion. That's pretty cool. And we're getting assert null true here because if we look at our implementation, we're not really getting anything here. I mean, if we returned foo from here, then that would probably fail. Oh, it totally doesn't. It totally doesn't. Yeah, good thing you weren't spamming, hey? I'm not sure why this is actually failing. Okay, there we get a failure. There we get a failure. Okay, so this is failing because, I mean, this passes initially because we're not returning anything from there, and so the return value is just being equated to null. Sorry, Greg, sorry. I'll turn these buttons off, actually. Let me turn these buttons off. I'll leave banning to you, okay? Greg, you are the ban master. Don't let me down, Greg. Ban those spammers. Okay. Because this is a yield, let me just recap because I'm kind of waffling on a bit. Because this is a yield, PHP unit wouldn't run this code initially. We had to wrap it in a coroutine and we had to do done. I'll explain the done in a while. And because it's a coroutine and that depends on the event loop, we have to run the event loop. But that means that this is functioning now. If we go back here, it runs that assertion, and because the function isn't doing anything meaningful, the assertion passes. So maybe that's a bit of a fake test to do. But when we start writing the implementation of this, we'll see this will start failing because we'll be returning interesting stuff. I think that's a good place to stop for the break. So I'm going to be getting some water for 2 minutes, and I will see you in a little bit.